Hi everyone, we are going to continue to jump into logarithms today. I did want to mention from our last lesson when we talked about the graphing of logarithms, we will be talking more about transformations later on in the course, which is when a function goes left, right, up, down. But for logarithms, we really just wanted you to get an idea of what the graph looked like. And if, let's say, you were given a picture of this, could you identify the domain and range? And the main thing is the range is all real numbers, and the domain is the one that has restrictions. And oftentimes those restrictions are based on this asymptote, which means that a function can get very, very close to some value but not touch it. And that value can be found, again, by setting that whatever is in the parentheses equal to 0 and solving. That's where the asymptote exists. That's what we can't touch. Just wanted to kind of add on to what was mentioned in the previous video. And to kind of continue to add on to our knowledge of logarithms, it's important to know, again, that logarithms and exponential functions do have a relationship. And that relationship is that logarithms, again, and exponential functions are inverses of one another. But the other important thing that you should know is, again, that this is read log base 10 of 1,000. This value, I should say, to get the larger value, not even the larger, larger text, this value, or 1 over 100, or 25, or 1/9, all of these values have a relationship with the base, the little number. And to find this value, and when it says evaluate the logarithms without a calculator, this is equal to something. I don't know what it's equal to. It's equal to some number x. Let's just pretend. I don't know. It's just whatever it is, right? Let's x, a, b, c, d, whatever. But it's equal to something. And we don't know what that is, so we're going to call that unknown x. And if we want to figure out what this is equal to, I can ask myself, x to the power of what gives me 1,000? That is the relationship that exists here. 10 to the power of something is 1,000. That something is the answer here. Okay? 5 to the power of something is 25. This one's a little easier. Here, x is going to equal to 2. If I evaluate this answer is just the relationship, the exponential relationship that exists between the little number, the base, and the big number, 25. There is a little rule that we're going to look at, but right now we're just kind of thinking through it. So if you're like, all right, 10 to the power of what gives me 1,000? Well, if I do 10 to the power of 1, 10. 10 squared, 100, 10 cubed, boom, 1,000. That means that my answer here is 3. You don't have to put x is equal to 3. You could just put 3, but I kind of identified this as being x, so that's why I'm doing x is equal to 3. And basically, a lot of the times how that's set up is 10 to the power of what is equal to 1,000 is another way that you can think about it. And we figured out that 10 cubed was equal to 1,000. I could do the same thing here. I could say 2 to what is equal to 32. Again, that relationship. 2 to the power of something gives me 32. So focus this. There we go. So I'm going to put it in my calculator. 2 to the what is 32. And I keep kind of guessing, checking, and then I eventually get to 2 to the 5th is 32. Okay. Now, there's lots of fractions now going to happen in these other ones, which are a little weird, but that's okay. So again, if we read 10 to the power of what gives me 1 over 100, that's weird because a lot of the times it's been getting bigger, but that's okay. We can still do this. This is a little bit of prerequisite knowledge, but that's okay. I'm going to go ahead and kind of talk about this really quick. So let's just think about what 100 is in relationship to 10 as an exponent. Do you agree that 100 is the same thing as 10 squared? So I'm going to rewrite that. So 10 to the x is equal to 1 over 10 squared, okay? I just changed 100 to 10 squared because, again, I'm trying to say 10 to the what is getting me to 100. So I'm kind of just putting it in the same terms. Again, a little bit of prereq knowledge, but if you have a squared in the denominator and you want to move it up to the numerator, right? I don't like fractions. I don't want to see fractions. You can rewrite that as 10 to the negative 2. If you want to move an exponent from the denominator to the numerator, you can make it negative. That then tells me that basically 10 to the negative 2 gives me 1 over 100. So let's check. See if that works itself out. What is the value of 1 over 100? 0.01. What is the value of 10 to the negative 2? 0.01. See, they are equivalent. They are the same thing. We are just making it look a little different. So x is negative 2 here. I'm going to let you go ahead and try number 5. Zoom out really quick so you can see all this. And you will get an answer of negative 2 again. And I'm going to go ahead and do number 6. So pause the video if you need a chance to do number 5. Again, this is saying 6 to the power of what gives me 4. This is weird. I'm getting smaller. Well, let's think about this. What is the square root of 16? Square root of 16 is 4. You can write exponents, radicals as exponents. Okay, what do I mean by that? The square root of 16 is the same thing as 16 to the 1/2. So if the square root of 16 for these purposes could give me 4, then 16 to the 1/2 could also give me 4. Sorry, I'm trying to make this focus. So in this case, 16 to the 1/2 is equal to 4, which means x is equal to 1/2. Almost put 1/4. Sorry about that. Okay, this is if you're just kind of thinking through it and you're making sense of it. Again, we're going to have a little formula in a second, but I wanted you to just kind of think about and start to understand the relationship that happens between this base and the big number here. You can also do logarithms in your calculator. I figured it out. I know in my previous video I wasn't sure, but I looked it up. It's true. You can press, the math button and then select A. Okay, let me show you. All right, here we go. I'm going to select my math button. And I'm going to go down, all the way down to A. And it says log base. And it has 2 areas that you can input values. So I'm going to put log 10 of 735 in my calculator. And basically this says 10 to the what gives me 735. And that would be about 2.87. So this, why do we do this? Because, let me write this really quick. For the calculator. Why do we do this? Well, we can kind of think through these and say 10 to the power of 3 is 1,000. But when it's not a whole number, it makes it hard. And so sometimes you can definitely do it in your calculator. So I'm going to do one more of these. I will do 4, and then I'll let you kind of look at the rest on your notes and try them on your own, just because it's putting it in the calculator. So that's pretty straightforward. So log base 2 of 5 is equal to 2.3. So again, 2 to the what is 5? Think about 2 to the 1, 2. 2 squared, 4. 2 cubed is 8, right? So we skip 5 basically. And so 2 to the power of 5 is somewhere between 2 and 3. Where is it exactly? It is at 2.3. And again, you wouldn't have been able to do that by hand necessarily. Oh, sorry about that. So again, I will let you go ahead and finish up the rest of these, and we will move on. Okay, so let's get to the rule here. How do we use logarithms to solve for x when we have exponential functions like this? Remember, when x is as the exponent, it messes everything up. We kind of were thinking through these examples earlier, and I kind of made an x and I put it in the exponent as part of our thinking through process. Sometimes you will just be given an equation where the x is in the exponent and you think, oh my gosh, what am I supposed to do? Because logarithms and exponential functions have a relationship, you can convert from logarithmic to exponential form and vice versa. And here's what the relationship says. It says if it's an exponential form, this a is the base in the exponential equation, and it's also the base in the logarithmic equation. X is the exponent, and like earlier, it's what we set our equation equal to, right? Like when we were actually converting earlier, which is kind of our thinking through process when there was a rule. So I just set it equal to x, and I said, okay, this logarithmic function is the same thing as 10 to the x equals 1,000, because we're thinking 10 to the what gives me 1,000. So the x's are there, and with the exponential equation, the y is what it is equal to. The y is the output. And here it is what is directly associated with a, with the logarithmic function. So here's a few examples. You can convert from this exponential function to this logarithmic function. And there's a few different examples. I kind of like to think that sometimes, let me write this really quickly. For example, this log base 2 of y equals x. Again, you're saying 2 to the what equals y. But sometimes I also like to just say, okay, this base, come on. There we go. This base is going to push up this value if I'm going to move this from logarithmic to exponential form. So from logarithmic to exponential form, this is going to be the base. It's pushing up the x, and it's equal to whatever that big number was. So, and then when you change from logarithmic to exponential to logarithmic form, this big number with the exponent is always your base. So if I'm going from exponential form to logarithmic form, this is my a. 2, 5, and come on. Let's see if this will work. Sorry, guys. Okay, there we go. Okay. So 2, 5, and 3. E are going to be my a in this case. So this as a logarithm is log base 2 of whatever it's equal to equals to x. If you want to try the next one, go for it. Pause the video because I'm about to do it. So log base 5 of what it's equal to, 10, is equal to x plus 3. You don't have to do parentheses, but I like to, just to kind of be a little dramatic about it, and just remember that that's kind of my my y value technically, if you want to put a variable to it. If you want to do this next one, you can. You're going to end up getting log base e of 5 equals 3x. Log base e, again, we talked about this previously, is the same thing as ln. All right. We can also go from logarithmic to exponential form. Again, I just kind of say, I'm going to take that number and push it up as an exponent. But again, you're saying 3 to the power of what is 81? And it actually already tells us 3 to the power of 4 is 81. If you're given anything as ln, you need to go ahead and change it to log base e before you can turn it into exponential form. So ln is the same thing as log base e. If you want to go ahead and pause the video, you can. Try it yourself. But again, this is the same thing as e to the power of 5 is equal to x plus 1. Again, you can equal something that's other than x. That's fine. It's just whatever is in these parentheses is what it's going to equal. If you've got a log with no base, remember the common log is 10. So if it's not numbered, you can assume it's 10. So this is the same thing as 10 squared is equal to 4x. And we're not yet solving, but we will be doing that soon. So we have just been converting from logarithmic to exponential form. Okay, in this last little bit, you will just be practicing. And so I'm going to leave this to you. This is a weird angle, sorry. I'm going to leave this to you. You've got the key online, and at this point, you should be able to do homework 7. So now we are 5 through 7. You are able to do, and we will continue working on these problems and logarithmic functions in the next video.